What I'm going to talk about a little bit here is just some code compaction techniques. As Jacqueline mentioned, I've been working with a customer that's been taking traditional code, and we've been refactoring it for them into Synergy.net. The code compaction is something that I'm pretty passionate about. We can also call it code bloat. In essence, code bloat is excess or unused code in your programs. Some of the immediate negative effects are going to be performance, although the compiler is usually pretty good about optimizing a lot of your large code out. But there are still some potential performance issues, especially if you are creating objects that are maybe unnecessary. So that's an immediate negative effect of large code. Long-term effects are much more significant, the biggest of which is the larger a piece of code is, the harder it is to determine what the intent of that code is. And so somebody that's going to be looking at it 6 years down the road, 10 years down the road, or 30 years down the road, like I am, may look at something that is 300 lines long and just kind of scratch your head and say, what is this thing trying to do? So hopefully we'll go through some examples of some techniques that I've found during my project with this particular customer. Hopefully you can glean something from it and learn from what I've learned over time. So the first code compacting technique is the creation and initialization of variables. And what I've done there is shown you 3 different forms of exactly the same code. The long form, what you're doing is you're defining a myObj, which is a myObject class, and then the next line below that, the myObj equals new object, actually instantiates that object. The local int is a similar type of defining a local int variable as an int, and then indicating or setting it to the value 500. The intermediate form below that is essentially the same information, just compacted into 2 lines. So we took 4 lines and compacted into 2. The short form is really the one that you ought to prefer. And if you notice that in the short form for the myObj, we no longer specify that's a myObject type. It is implicit in newing it up that it's going to be a myObject type. And that way, if you ever change what myObject is, you can simply rebuild it. You don't have to go back and say, oh, it's now no longer at myObject, it's at myObject2 or something like that. So the same thing with the integer variable. If you're going to remember any code compaction technique, this is the one that I think you're going to get the biggest bang for. An object initializer. Basically, when you create a variable, you're going to define what it is, and then you're going to define the fields within it to be some sort of a value. And you can see there in the long form, just with a handful, 4 variables, we're taking up 5 lines of code. And in essence, all you're simply doing is saying, go and create me the object, and by the way, these are the values of those fields. The object initializer pattern, which is this line right here, instantiates that object for you, and then within the same line, or you can cut it and drop it into the next line, you can define those variables very quickly. Another very similar type of compaction technique is constructor arguments. So you see here the same number of lines in the long form. In the short form, it's slightly different because what you're doing is you are passing the values for the fields as arguments to your constructor, and which requires that you in fact have a constructor that accepts that specific number and type of arguments. Ternary pattern is another one. I like this style. If you take a look at the short form first, it's very immediate what the intent is. I'm trying to define what the value of hourly rate is, and it's going to be based on whether in fact this person has worked less than 40 hours or greater than 40 hours. So you're saying that the hourly rate is either going to be that person's target rate or its overtime rate. Okay? To me, it's much clearer as to what the intent is compared to the long form. Null coalescing, very similar, except that here you're testing for null versus a condition. Some of these next ones are going to be, I'm just barely touching on what the subject is. Inline lambdas and delegates. Again, you can see from the long form there. All we're doing is we're simply saying, go and sort it by the name. And by specifying an inline lambda, you can reduce those 4 or 5 lines of code into one. Just one warning there, don't go overboard on inline lambdas because you can confuse yourself by putting too much information in the inline lambda. Extension methods are another way to get some code savings. It's not immediately obvious. In fact, it is not obvious here. Again, this is one of these things where you improve the intent of what it is that this thing is doing. So instead of saying, for example, if the list is not null or is greater than 0, then do something. It's valid. Whereas if you defined an extension method called is null or empty, you could just simply say, is that list null or empty? Link on collections, again, I'm not going to expound on this one. There's a lot of information about link that you can glean online, but basically what you can do is do things like select from your list based on a value. And you can see there the long form versus the short form. And then here, what you're doing is you're saying, give me the first element in that list that matches that particular value that I'm looking for, which in this case is int var equals 1,000. Thank you very much. Sorry I ran over.